Good morning, guys. Don't know if anyone's here, but if you are, let me know. Morning. Looks like I got some people in there. Any questions you guys have, let me know. Hey Hunter, can you go over Unit 7, Part B, Question D? Yeah, no problem. Give me 1 second. Unit 7, Part B, Question D1. Alright. Okay, so let me open this up real quick, Hunter. But you know, when I'm streaming, it's going to take about 10 minutes. So question 7D. And you wanted to go over part I, it looks like. All right. Okay, so this question says to, use Euler's method, starting at t equals 0, with 2 steps of equal size, to approximate the total amount of liquid fertilizer injected into the growing system by time t equals 1 month. Show the computations that led to your answer. So, big hint right here is, first of all, use Euler's method. Okay, that's number 1. So we know we have to use some sort of step estimation. All right, and they even say with 2 steps of equal size. Okay, so with Euler's method, first things first, we were using x a lot, but it's just whatever the variable is. In this case, the variable is t, so I'm going to keep it consistent. I'm going to use t. So we first need to find the step size. Well, we call the step size change in t. So what that means is just between each step, how much is t changing? Well, we know we're going from t equals 0 to t equals 1, and we know we have 2 steps of equal size. So that means in order for 2 steps to get to 1, each step has to be 1/2, right? Because 1/2 plus 1/2 is 2 steps, and that would be equal to 1. So we're starting at t equals 0, we want to get to t equals 1. Okay, so that's the first step. So we got to get change at t equals 1/2. That's our step size. Next step is to get our 0th terms. So our t value and our big F value. Again, I'm using t and f. You could have used x and y as long as you were, as long as you labeled what they meant. So as long as you were specific enough to label what they meant. And they give us actually our starting value. So we know that t of 0 is 0. We're starting at time t equals 0. So to find what f of 0 is, well, f is representing the amount of fertilizer. And they tell us at the beginning of the problem, if you read the question, it says that at time t equals 0, 3 liters of fertilizer are injected into the system. So we know that f of 0 is equal to 3. At t equals 0, f equals 3. All right, so we got our first, the very beginning of it. And then we proceed by finding our steps. So my first step is when we go up 1/2. If our step size is 1/2, then our first step would be up to 1/2. And I need to find, should be what f sub 1 is equal to. So if t sub 1 equals 1/2, what is f sub 1 equal to? All right, and the formula we use is we're going to use f of 0, so 3, plus f of the point 0.03 times 1/2. You might see this represented in various ways. All this is saying is I want you to use the function that was given to you and evaluate it when x is 0 and when y is 3. Or in our case, when t is 0 and when f is 3. Okay, so if I were to do this, my formula, so the 3 stays the same, and then plus. The formula is 1/3 times f times the quantity of, 6 minus f. So 6 minus 3, all times 1/2. So again, I'm just using my formula, Hunter. I need one more set of parentheses there. That 1/2 is being distributed to f of 0.3. Okay, then we have calculators. This one's a pretty easy one to solve, but what we end up getting for this is 9/2. I'm going to put a little box around 9/2, just so I can separate that, because I'm going to need that for the next step. Okay, and we have to do this one more time, because the question asks for the step size of 1/2, and we want to estimate when t is equal to 1. So, I don't want to put that. So my second step, that's what t sub 2 means, my second step would be adding another 1/2. So I get to 1. So now I'm at 1 month. This will be my estimate for 1 month. All right, so I need to find f sub 2 then. And it's the same idea, okay? Instead of using f sub 0, though, I'm going to use f sub 1. So the previous step. So I'm going to have 9/2 plus f of 1/2 comma 9/2, and then times 1/2. Proceeding with that, I'm going to have 1/3 times, instead of 3, I'm using 9/2, times 6 minus 9/2, all times 1/2. And you can use a calculator to solve that, no big deal. And your final answer is 45/8. And that's it. Yeah, your final answer is 45/8. How'd that go for you, Hunter? Does that make sense? Yeah, no problem, Hunter. Glad I could help. Can you go over Unit 8, Part B, Question B? Yeah, sure, Hunter. Unit 8, Part B, Question B. Okay. So, Hunter, this one was asking for the perimeter. So this was 8B. So, yeah, it's asking for the perimeter. And the way I justified it, kind of just telling myself out, was I was like, okay, well, the perimeter's got to be, if I were to have this on a piece of paper, I would shade the region, right, that I'm looking at. And the perimeter is just adding up all the sides, correct? Well, we have two sides. So, like, I call them side 1 and side 2. We have, like, a base, which is just the x-axis, however long the x-axis is. And then we have a curve. Like a weird curve. Those are the three things that we want to estimate or find, really. Okay, so sorry, I'm still trying to open this up. It's going to take another year. I'm going to split this up then into different sides. So side 1, side 2, base, and then the curve. Of course, my computer's being annoying. I think it's okay. I think I remember everything that's going on here. So, the first side, to find the side. All right, so I'm just looking at the length of the line, right, on that side. And when I say the first side, I just mean like the farthest left up and down side. So to find the height, right, of that line, all you got to do is to just find f of that point. So in this case, we start at 1. So we need to find f of 1. Well, f of x is 1 over x. So 1 over 1 will give me 1. Okay, so that's my side number 1. Side number 2 is then going to be the length of the line at x equals k. So when x is k, what's the length of that line? Well, again, we just have to evaluate the function because that gives us the height of the line. And so to find evaluate the function, you use the function 1 over x. But instead of x, we're at the point k. So my side 2 is going to be 1 over k. Okay, and then the base. All right, so the base you can see is just a line from 1 to k. So to find the distance from 1 to k, right, we just take k minus 1. You find the distance of anything. You're just going to take the end point minus the beginning point. Jeez, my computer is out of whack right now. I apologize. Hopefully my stream's okay and you can hear me. Okay, now the last part is the curve. And the curve gets a little bit more challenging because the curve actually brings in calculus. So everything we've done so far, no calculus has been needed. Now we actually need to use calculus. So all we're doing is we're finding the length of the curve from 1 to k. So the actual curvy part. That's what we want to find. Okay, and to find the length of the curve from 1 to k, we have to use our formula. And that formula is this. The integral from a to b of the square root of 1 plus the derivative of y with respect to x squared dx. Okay, nothing more to it, just something you have to memorize. Okay, so we have this. Now I just got to fill in the pieces. Well, first of all, I'm going to need what dy dx is. Okay, because I can't use this formula without the derivative. So I know my function is 1 over x. What's the derivative of that? Well, the derivative of 1 over x is negative 1 over x squared. Okay, so using that, let's start filling some pieces. Okay, so from A to B. Well, I know the total area that I'm covering is from 1 to k. So my bounds are 1 to k. I still have a square root of 1 plus. My derivative is negative 1 over x squared dx. Okay, and I'm going to put that in a box just because I know I'm going to need that as well. Alright, so I'm pretty much here. Last thing I need to do then is just put it all together. So my perimeter is going to be represented by 1 plus 1 over k plus the quantity k minus 1 plus the integral from 1 to k of the square root of 1 plus negative 1 over x squared dx. And in that black circle there, that would be my final answer. All right, let me know how that went for you, Hunter, if you feel good about that, if you want to still have some more questions. Okay, cool. Yeah, so just mark that down somewhere so you have that. I think that'll be useful for you. Okay, Hunter, part C. Maybe I'll be able to open it up. All right, so I think, Hunter, the same idea here. It's just a formula. So if you remember when we find these volumes, so we're doing some sort of manipulation of the graph. We're saying, okay, imagine if we had cross sections, okay, of this three-dimensional shape. So we're kind of taking a two-dimensional shape, picturing it being three-dimensional, where we're rotating it about some axis. So in this case, oh geez, oh man. All right. In this case, what we're doing is we're rotating it about the x-axis. So if we're going to rotate about the x-axis, that means about x-axis, we're using the disk method. So maybe that is ringing a bell. Not sure. So that's what we'll be doing. We're going to be using the disk method. So using the disk method, here's the formula. So you might want to write this down, Hunter, have this somewhere. Volume equals pi times the integral from a to b of the quantity f of x squared dx. All right, and this will pretty much give you everything you need. So if I'm finding the volume, right, I still have the pi. What's my a to b? Well, in this case, the question, again, I can't read it because my College Board's being ridiculous, but if I remember correctly, the question said something about, find the volume if the function's rotated about the x-axis, if k is headed to infinity, or if k is infinite or unbounded. Some wording of that phrase is referencing the fact you want to find because we don't write k, we can see the graph, it looks like it's finite. We're assuming it's not finite. How do we approximate our value? Well, to approximate, we still start at 1. Okay, it's not going finite negative, it's just going to stay at 1. But now we're going to assume that k, my upper bound, is headed to infinity. So I replace my bound as instead of 1 to k, it's 1 to infinity. Okay, so now from here, I'm going to fill in instead of f of x, right? I know what f of x is. It's 1 over x squared dx. Okay, so the two things we did there was filled in our bounds and filled in the function. Okay, now from this part on, I don't think it's too bad. Now, I want you to remind you, though, before I let you go or try to do it yourself, remember when we're solving an integral, because we actually have to evaluate. We actually should get a value here. To solve this integral, that's called an improper integral. So in order to solve this, what I want to do is, let me do this first. So let me distribute that, let me square that. So it's the volume equals pi times the integral 1 to infinity of 1 over x squared dx. What I want to do to find this volume is then to take the limit as k heads to infinity of pi times the integral of 1. Instead of infinity, we replace it with k. This is how we solve an improper integral. Okay, and everything stays the same on the inside. And then you solve that improper integral and you'll get your answer. So I'm going to let you go do that. And then just in the chat, let me know what you get as your answer. Yep, you're right, Hunter. The answer is pi. Well done. Sorry, Hunter. I was just saw your question there. Hopefully you weren't waiting for too long. Can you go over Unit 10, Part A, Question 1B? Sure thing. All right. So, will I be able to open this assignment? Probably not. But I think I'm able to do this one without it. All right, so it's essentially asking you, it gives you this. So it gives you the series from n equals 1 to infinity of negative 1 to the n over n to the p plus 1. Okay, and the question's asking you, is this series absolutely convergent, conditionally convergent, or not convergent, or diverges? Okay, so that's what the question's asking you. In order to solve that, well, let's just first establish is it convergent or not. Let's just start there. So you have your methods, okay? Depending on what your method was, it's going to change like kind of how you get to your answer. So here's kind of my thought process, and I've told you guys this before, is try to use ratio test. Any questions involving absolute or conditional convergence, series ratios test is usually pretty effective because the ratio test will tell you not only if it's convergent, but if it's absolutely convergent. So, it's going to be a method we're probably going to use anyways. So that would be my suggestion, is just start there. You also could have done this, so just for practice, you could have done alternating series test, if you felt comfortable with that. So the alternating series test is saying that, is it decreasing? That's the first question. In this case, it definitely is. So I'm just going to put a little check mark because the denominator is growing faster. So the denominator is growing faster, the fraction is going to get smaller and smaller. The next part of the alternating series test states, does the limit as n approaches infinity of the inner, or the non-alternating part, is that going to be equal to 0? And in this case, it is. All right, 1 over n to the p plus 1 is going to definitely, that limit's definitely going to be equal to 0. Hunter, I went straight into ratio test, not try to cancel. Okay, so yeah, I'll just show you that anyways. All right, so you can see it. That's one way that proves it is convergent. But yeah, you do have to use ratio test to prove if it's absolutely convergent. So hopefully you have the first part here. We have the limit as n approaches infinity of the absolute value of negative 1 to the n plus 1 divided by n plus 1 to the p plus 1 times n to the p plus 1 divided by negative 1 to the n. All right, so you should have that first step of your ratio, right? It's b of n divided by a of n in this case, or sorry, a of n plus 1 divided by a of n. Okay, and we just use multiplying by reciprocal because they're reciprocals. First part to cancel, it's absolute value. So alternating, it does not mean anything. Meaning that numerator and denominator, those are just going to be 1 no matter what. Doesn't matter what n is, it's always going to be a positive 1. Because 1 to any power is either 1 or negative 1. This case, absolute value, make it 1. So really what I'm left with is just n to the p plus 1 divided by n plus 1 to the p plus 1. Okay, so let's double check, see if you got to that part. Now the question is then, okay, we get here. What am I looking for in the ratio test? Well, the ratio test is saying that this has to be less than 1. All right, so that's part of the ratio test. We want to see is that less than 1. So you actually don't need to cancel anything. All you got to do here, Hunter, is just conceptualize. Okay, if I were to take this limit as n approaches infinity, so is this number, remember, p is a constant, p is going to stay the same. So the p and the plus 1, these are completely irrelevant. At the end of the day, all we're looking for is we're looking for the coefficients n and then n plus 1 of the basis here. Okay, n plus 1 is going to grow faster than n, meaning that the denominator is going to always be bigger than n, meaning that this always has to be a fraction that's less than 1. That's the only way this can be true, if this is a fraction less than 1. So this limit is in fact going to be less than 1. So by ratio test, it's absolutely convergent. All right, so more of a conceptual answer to that. Cool. Sounds good, Hunter. Hunter, if you're still here, hope you have a great rest of your day. If you have any more questions, it looks like you're almost done with the assignment. Go ahead and shoot me. Actually, honestly, Hunter, you could probably hang out. If I don't know who's going to be in here for Calculus AB, but if you have any more questions, Hunters, you know where to find me. Just let me know. How is everyone from AB? Looks like I got some people here, so let me know if you're here. Go ahead in the chat. Go ahead and type. Morning, Haber. Good morning, Jasmine. Hey, happy Friday, Alexis. That is right. Anyone have any plans for the weekend? I mean, I got to imagine it's going to involve being inside, but anyone have anything creative or fun they plan on doing with their family or anything like that? Morning, Jonah. Morning, Andrew. Would love to hear if you guys are doing anything interesting or, creative, anything along those lines. Looks like more people are coming in. Let me know if you're here. Good to see y'all. So, Calc AB, I'm currently grading your guys' submissions over the spring break assignment. If you haven't done it yet, you can still get it to me some point today. So I'm not gonna finalize grades. 3:30 is the cutoff though for that work. Just because it's first of all Friday, today's the last day of the quarter. Okay, technically, so just understand that. So in all your classes, make sure you guys have all your assignments in or whatever you need to get done because today is the last day. Some teachers might accept late work. I'm not accepting any late work for that the spring break work. So yeah, if you're in here right now and you're like, oh, Mr. Harris, haven't started it, haven't done it, haven't looked at it, you got it yet till 3:30. All right, and then after 3:30, I will hopefully have everyone's graded and finished, and I'll give you guys your scores. And then what you see in your grade book will be your third quarter. All the stuff from this week will go on fourth quarter. So I'll still grade this stuff, but I think I want to put it into the fourth quarter grade instead. That's where my head is at right now. So before, first of all, I mean, you guys know if you're in here expecting me to do any sort of notes or lecture or anything, that's not what I'm doing today. Friday is just a review day. So you guys are all here, optionally. I'm not teaching anything new. I'm not going over anything new. I'm just completely here to answer your questions. So before though, I mean, now is a good time to say this if anyone's interested. I did get an email about the grading scales and everything for this quarter. So here's the idea is that third quarter you're not going to see really a grade for. From my understanding, I think I understand this correctly, you won't see a grade at all. Grades won't be sent out. I don't really know exactly how that's all going to work. That's just kind of what I've heard. So it doesn't mean that quarter 3 doesn't exist. It just means that what's happening is quarter 3 is going to be taken normally. So like it would just as if we were at school. You're going to get like a C, a B, an A, or D all on that same grading scale we've always used, whatever. Now the fourth quarter though, and the second semester will all be on this new grading scale. The new grading scale, if you guys haven't heard, is 80 to 100 is an A, 60 to 80 is a B, and I believe 40 to 60 is a C, I think, or 20 to 60 is a C, something like that. I know it's a big difference, but I can't remember which one it is. Regardless, though, you can tell you got to work pretty hard not to pass. And if you don't, you're not failing either. There is no Fs. So you're just going to get a P, I think it's called. Mr. Snook made the joke that stands for pandemic, but I genuinely don't know what that means. So even that, not really sure. But, that's here in calculus, we have more important things to worry about than all that. So we got an AP test coming up. But just so you guys are aware of how this is going down, another thing I want to address, and I'll definitely talk about this more as the time comes, I really don't know what's happening after the AP test for you guys in terms of not only this class, but any of your classes. Jasmine passed probably, yeah, maybe. If that's the case, then everyone passes, I guess. I don't really know. I'm not worried about anyone, especially not the people who are at the stream right now. If you're in the stream right now, I'm not worried at all about you passing or even of you not getting an A. Okay, I think everyone's going to be getting A's. That's not what my concern is. So after the test and everything, I don't know if any of you have thought about that. I know I have, just because I'm curious as to what is expected. You're done with AB after this. So I don't really know what my original plan is to do. We were going to do some fun stuff, some projects, maybe watch a movie, something like that. Now, looks like I have no clue. So I'm going to have to eventually at some point, reach out and figure out what's happening after your AP test, because I don't know what other teachers are planning on doing. I know for me, I was going to do projects with each other, and that's not going to be really feasible because you're not going to be in class working together. So don't really know what my plan is. I might have to adjust. I might have to think of other things, but whatever. I'll figure that out future me. I'm just kind of talking now. So anyways, right now, any questions you guys have over the week's work? I don't care if it was during a lesson of mine. I don't care if it was during homework. Whatever questions you guys have, go ahead and fire them off. Just so you know, my College Board is being a little funky, probably because I'm trying to stream and grade your guys' assignments. So it is kind of being a little weird. While you're typing in your questions, also, I do want to address that while I'm grading your spring break work, here's how I'm doing it, just so everyone's aware. First of all, thank you, those of you, and I'm sure all 10 of you who are in here did submit it. But thank you for that. First of all, you guys did, from what I've graded so far, you guys did a good job. I'm going to grade these as if it was an AP test. So I'm grading each portion exactly using the grading scale, like the grading rubric that AP has. So just as if you were to submit this as your AP test, what would your score be getting back? So I'm treating it just like that. My video was a way to get 100%. Okay, unless maybe afterwards, maybe when you guys get your grades back, you might be like, wait, Mr. Harris, you never said this, or you correct, said something wrong. I don't know. I tried to give 100% every question. Maybe I missed something or misspoke. I don't remember. I didn't watch the video over, but you guys can help me with that after the fact. So after I give your submissions back. But my video, as far as I know, should have given you 100% if you followed that. So if you didn't, that's probably where some errors might have happened. If you did, you're gonna get 100% on the assignment. But that wasn't ultimately my goal. My goal is to give you feedback and let you know like what it takes to get 100% or to get every single point. So what I'm doing is you'll be getting yours back. If you get everything right, I'm not gonna make any comments. Maybe a comment that says great job, something like that. But if you did everything right, you get your score, your full credit. Good job. If you miss points, I will tell you what points you missed and why. So if you got a 1 point out of 4, I'll tell you where that 1 point came from and what you missed. So when you guys get your feedback, you'll be able to see my messages. You'll see your grade in PowerSchool and in AP Classroom. All right, so just keeping a lookout. I don't know when I'll have it done. I would like to have them all graded at some point by the end of today. They do take a little bit of time because there was 3 assignments, and once I stop streaming, it'll go a little quicker because my internet's really slow when I stream. So eventually, I'll get through that quicker. Hopefully, I'll have it done by today. That's the plan. Anywho, okay. Haber says Wednesday's homework. Jasmine said pointing arrow up. Alexis said I'm not sure if this was Wednesday, but Unit 3, Part A, Question 1, Part C. All right. I love how these are labeled. Unit 3, Part A, Question 1, Part C. Okay. So let's start with Alexis's question. Haber and Jasmine, if you guys have a specific part you want to go over, let me know. If you want to go over the whole question, we can just do that. But keep funneling in questions. I'll see them all in a line, so I can just reference back when I want to go over stuff. But we'll start with Unit 3, Part A. So this was from Monday, Alexis. Unit 3, Part A. Again, I really hope I'm able to open up these assignments. It's been horrible today. And Alexis wanted to go over specifically Question 1, Part C. So Unit 3, Part A, and Alexis wants to go right 1C. Okay, so first things first, guys, you can use your graphing calculator for this question. All right, so that might be useful to you. Just always try to notice that. Okay, so 1C says, is there a value C for 0 to 3 such that g of c equals 5? All right, now here's your hint on these questions. Always some giveaways. So number one giveaway, is there a value C? Okay, that's a big giveaway. Whenever that wording is used, we want to be thinking about intermediate value theorem, also known as IVT. That's got to be something on our minds. So we want to think, if we're looking for value C, so, think of it as an x value between 0 and 3, where a function, so this is the second part, such that a function is equal to 5. This is all pointing towards IVT. Okay, and IVT is saying that, okay, well, in order to see if there's a value C, we have to first find two things. We have to say, well, is the function continuous? Is g continuous? That's number one we have to show or talk about. And then, what are our end values? So between 0 and 3, what are our values? Because then I can show if it's continuous and 0 is 0, and then at 3 it's 15. 5 is in between those. So I know I have to hit that point. I know it's been a while, so I do want to, this has nothing to do with the problem. So let me preface that. This graph won't have anything to do with the problem. But this is what IVT is saying in a nutshell, okay? I have this point at x equals 0, and then I have this point at x equals 3. Okay, and I have some continuous function. All right, let's just say that's my ugly continuous function. Again, this has nothing to do with the actual question. IVT is saying this, all right? I can prove that these endpoints, let's just say this is at 5. Okay, and then that's clearly at 0. So from 0 to 5. IVT is saying that, okay, I want to see, oh wait, let me change this. Let me make this 6. That's fine. If I want to see if there's a C between 5, well, first of all, I can look at the graph, and I can see this is continuous, right? There's no holes, there's no jumps. And I know I start at 0 and end at 6. So if I highlight this, right, I have to hit 5. There is no other, I can't do it without, I can't skip 5 unless I lift up my pencil, which would make it not continuous. That's what IVT is saying. It's just saying that I have to draw a solid line between 0 and that value, 6. So I have to hit every point in between. I have to hit 1/2. I have to hit 5/6. I have to hit 8/5. I have to hit 2. I have to hit 3. I have to hit 4. That's the only way I can do that. All right. So I know that was long-winded, but just as a reminder of IVT, I just taught you IVT in 2 minutes. Okay. So let's look actually at the question now. So first things first is I want to find g of 0 and g of 3. I want to find my endpoints. Okay, and they give you, what do they say? Let g be the function defined by g of x equals, okay, so they give us the fact, just as a side note here, in the actual question, they tell us g of x equals f of x squared minus x. All right, so if I'm finding g of 0, that's going to be equal to f of 0, because f of 0 squared minus 0. And then f of 0, you guys look at your table, so your table will give you your answer for that. Look at your table, you find where f of x function is, that row, you look at the 0 column, match them up, and you should get 4. And go ahead in the chat, guys, stop me at any point. As always, if I'm confusing or if you need me to reiterate something, just type in the chat and stop me. G of 3 is going to be equal to f of 3 squared is 9. 9 minus 3 is 6. So f of 6. Again, look at the table. Find the f of x row. Find the 6 column. And then look at that number. So I have 4 and 7 is my g of 3. Okay, 4 4 is less than 5, which is less than 7. So in other words, you can write that, or you can write g of 0 is less than 5, which is less than g of 3. That's saying the same thing. However you chose to express that is fine. I'm doing bullet points. It just breaks up the work a little bit. The last thing I need to do is then show is it continuous. I need to know if the function is continuous. This alone is really good. This proves that IVT is going to be applicable. And the only way I can know for sure, though, is if f is in fact continuous. So this is going to be using a sentence, no math involved. We know f is differentiable. So f is continuous. So Ms. Harris, how do you know it's differentiable? Well, you can take a derivative, first of all. You guys can see that they give you derivative values, so you can take the derivative. But also it tells you. It says in the question, the table above gives values of a twice differentiable function f. So if a function is differentiable, we know it's continuous. Now, maybe you're thinking to yourself, well, that's great and all, but doesn't the question ask for g? Aren't we curious of g of c? And you're right. But we need to understand this, because g of x is equal to the composite function of f. So in other words, g is a composition of a continuous function f. So g is continuous. Any function that's made up of a continuous function is also in fact going to be continuous. So I know I wrote that very messily. But again, let me read that to you. F is differentiable, so f is continuous. G is a composition of the continuous function f, so therefore g is also continuous. So that's kind of like the hard work, proving that. My final answer, I'm going to write in blue here, right up here, is by intermediate value theorem. You're probably going to want to actually write that out. So you're going to want to write intermediate value theorem. Don't do IVT. I don't know if they'll mark that wrong. They might not, but just write intermediate value theorem. There is a value, c, for 0 is less than c, which is less than 3, such that g of c equals 5. So that would be your final confirmation for that. All right, any questions on that before I go into the next part? Jasmine, could we just say that G is continuous? That is a good question. Let me open up the scoring guide real quick, Jasmine, and see if maybe sometimes the scoring guide can be kind of difficult for to process. It's so. Here's what I'll say, Jasmine. Here's what I'll say. All right, this isn't great advice, but I think it actually is pretty good advice. If you're confident to use IVT, and you're very confident you need to prove that a function is continuous, but let's just say you weren't really sure this process, like you weren't really sure that how to say it's continuous. I would recommend, at the very least, just pretend. Just say it is continuous. So yes, just say G is continuous, and then show this part, and then go on. And I think you might get full credit. The explanation they use is that they use this explanation. So they talk about this. I'm not positive, Jasmine, because technically, AP can just say, oh, they just knew that in their head. Like in their head, they said, oh, F is differentiable, which is continuous, so G is continuous. And then they might give you credit. So my answer for you is, if you're not really sure how to prove it, but you know you have to use it, just say it's a fact, and then I hope that you get full credit. That would be what I say. Better safe than sorry, though. Just, yeah, understand that principle. Good question, though. Okay. It looks like Peyton and Emma are both asking for the same assignment, which is Wednesday's homework. I'm assuming, Peyton, you said part 4. I'm guessing you meant part A. I'm not really sure, so maybe in the chat. Because I don't know if you're talking about tonight's or the weekend's homework, or if you're talking about the Wednesdays. But Haber said let's just go over all of Wednesdays. That's fine with me. So let me open that up. Peyton said, okay, yeah. So let's do Wednesday's homework then, guys. So if you haven't done it yet, go ahead and get that open. I'll go through them. If you have done them, still have it open. We can go over some answers. You give me about 10 days to get this open. Man, I'm hungry. I should have ate breakfast, guys. I'm always making that mistake. I ran out of my Cliff Bars, though. That's usually my breakfast. All right. Just get a nice, fresh new page. Uh-oh. I need a notebook. Oh, wow. It actually opened. Okay. This is a very long question, right? So this is Unit 4. FRQ Part A. Very long-winded question. Okay, and it says, for time 0 to 10, water is flowing into a small tub at a rate given by f of t equals arctangent of pi over 2 minus t over 10. Let me preface all this by saying that you're allowed to use a calculator for this, which is going to be huge. It's absolutely essential. So, calculator, if you guys don't have a calculator out and you're doing this with me, get a calculator out. No, Alexis, thank you for asking. I don't need you submitting the assignments we did in class. The assignments we do in class, the assumption is that you get all the answers right and you copied everything that I put, so you're good. Obviously, not everyone's in here, but that's okay. Homework is what I want you to submit. Okay, so, yeah, all right, let me continue with what I was saying. F of t is the water flowing into the tub. So that's the rate at which the water is going into the tub. L of t is the rate at which the water is exiting the tub because it's leaking. Stupid tub. F of t and L of t are both measured in cubic feet per minute. T is minutes. The volume of water in the tub, so just the volume, is represented by W of t. All right, so couple big things, okay? Number one is the fact that we have rates of change. So we want to be thinking back to, those units on related rates, stuff like that. All this stuff we do with the rates of change, and we know by now, hopefully, rates of change equate to derivatives. Okay? So F and L are both rates of change. W is not, though. W is just a volume. F and L are rates of change of volume. This is just me, before I even start answering questions, this is running through my head, right? So that's kind of some of the stuff we're thinking about, okay? Another big thing is the tub isn't leaking until 5 seconds. So the tub is just filling up naturally. So, imagine that the leak is actually higher up in the tub. So it takes a while, it doesn't leak until it actually hits the leak. And that's from 5 to 10. Okay, so all this stuff might prove helpful. So let's start with 1A. At time t equals 3, there are 2.5 cubic feet of water in the tub. So at t equals 3, 2.5 is going to be equal to, I'm just going to say is going to be equal to, or how about this? Let me cross that out. Let's just do W of 3 is equal to 2.5. Okay, we know that. That's given to us. We want to write an equation for the locally linear approximation of W at t equals 3 and use it to approximate the volume of water at the tub. Okay, big words, locally linear approximation. We have a formula for that. We have a formula for local linear approximations. All right, that alone is going to be a huge part of this question. We need that. All right, and we need to approximate it at t equals 3.5. Okay, so the general outline of this is going to be f of x is equal to f of a plus f prime of a times x minus a. That's our local linear approximation formula. So if you guys don't have that written down anywhere, you might want to write down for this problem in case you're on the AP test and there's a problem just like this and you want to reference this problem. You'll have the formula there and you can just kind of manipulate the numbers. That might be useful to you. If not, you have it in your notes somewhere. Where that's at, I don't know. It's your notes. But it's somewhere in there. Okay, so I need that to understand. Now, the big parts of this, I guess I can add just so you guys know, if you're curious. X is going to be equal to the actual value. A is going to be equal to, I'm going to call it just the reference number. I don't know. There's definitely a word for that I'm probably just blanking on. I'm sure it's in your notes somewhere. But to talk about what I mean by this is x is the actual value you're approximating. A is just the number you're using to make that approximation. So in this case, t equals 3 is going to be equal to A. And then our actual value is 3.5. I'm using x and a. In our actual question, it's t's, right? So t is in place of x. All right, so let's get started. I'm going to need f prime. Okay, so in our case, let me actually just write this out. If I'm going to translate this formula into our situation, I need to find w of 3.5. That's what I'm approximating, is approximately, instead of f, we're using w of 3 plus w prime of 3 times 3.5 minus 3. Okay, that's ultimately what I need. By the way, in the chat, if you guys can't read, I might need to get a new marker. Let me know if this is too light for you. I can see if I can snag another marker here in a second, but this is the formula I'm using for the entire problem. This is what I need. This will give me the answer. So I just need the pieces now. I got w of 3. I found that. That's given to me, 2.5. I need to find what w prime of 3 is, and then I'm good. So let me just do that. Shouldn't have wrote that error. Whatever, I'll just do it below. I need to find w prime of 3. Okay, guys, so this is where it takes some conceptual understanding. I need to find the derivative of the volume. If w of t is representing of the volume, I need to find the derivative of that. Well, let's think about what that means conceptually. The derivative of a volume is the rate of change of volume. Well, I have two equations that represent the rate of change of volume. One equation is f of t, one equation is L of t. How do I choose which one to use here? So I need to think to myself, okay, well, f of t is the rate at which the water is flowing in. And that's represented from time t equals 0 to t equals 10. In this case, I'm at time t equals 3. So the water is definitely flowing in. But now my question is, though, is it flowing out? Because I might need to make some sort of difference if it is flowing out. But the water doesn't start flowing out until time 5. So until after 5 minutes, the water is just going to be flowing in. There's going to be no water exiting. So at the end of the day, then, the rate of change of volume is all dependent on what is f of t. In this case, I'll just erase the whole thing. What is f of 3? What's the rate at which the volume is changing as water is flowing in? That's what I'm looking for. So w prime of 3 is just equal to f of 3. And then for here, guys, you would just use your calculator. And you get 0.904089. Okay, so now all I'm doing is I'm replacing the values I know So I now know W3 is 2.5. I know W prime of 3 is 0.904089. I know x minus A is 3.5 minus 3. Got all this beautiful information, and I use my calculator, and I get 2.952 feet cubed. That's my approximation of the volume at time t equals 3.5. Any questions on part A before I continue? Specifically about the conceptual ideas. Okay, no, nothing yet. Maybe if you'll type something and I'll see it in a second here. But I'm going to keep going. Part B, 1B. It says, pretty simply put, just find the second derivative of 8. So the second derivative of W at t equals 8. So 8 seconds. All right, so let's first again think conceptually. What does W second, or W double prime of 8, what does that mean in the context of the problem? Well, we just said W prime of t is equal to the rate of change of volume. So W double prime of t is going to be equal to the rate of change of the rate of change of W. Okay? So this is actually not too bad to solve. So first of all, we need to find the rate of change of the rate of change of each part. And the reason I say of each part is because at this point, at 8 seconds, water is not only flowing in, but water is also flowing out. So what I need to do is I need to find the difference between the rate of change of the water flowing in, oops, wait, that's right, yeah, that was good, minus the rate of change of water flowing out. Sorry, let me rephrase that. I need to find the rate of change of the rate of change of water flowing in at 8 seconds, and the rate of change of the rate of change of water flowing out, or leaking. So F prime at 8 and L prime at 8. And to get what the actual volume is, you just take the difference, right? Because you have to take what's going in minus what's exiting. That'll give you the overall rate of change of volume. Now this looks ugly, and it is. But this question is nice enough to give us our calculators. All right, so all we would do is use our calculators. Now, I don't want to take it for granted. So right now, I want you guys to speak now or forever hold your peace. Do you know how to use your calculators to solve this problem? Or do you feel 100%, 1,000% confident you could? No issues. And in fact, if you want to, go ahead and do it right now. And tell me what answer you get. But if you guys would like me, I can go step by step how we put this in our calculator to actually solve. Because if you can do all this work and then not be able to put in your calculator in your AP test, that's no good. So go ahead and don't be shy. No one cares. And if you say it, I'm sure other people will agree if you want to go over it. But I can't move on without knowing that you guys can do that. Or maybe you just need me to preface what I mean by plugging it into my calculator. Jasmine says steps. Yes, okay, thank you guys. I appreciate it. All right, that's all I need to hear. All right. So let me do that. Let me double check that you can see this. It'd be sweet if I could just do this on my computer. If I had like this app, I should do that for next year. I should get this app. Hold on, give me a second. See if that makes a difference. Oh, that's better. Okay. Okay, so first things first. I need to find f prime of 8, and I need to find f or L prime of 8. So I'm given both functions. Okay, so what I'm going to do is first, I'm going to just do f prime of 8. So here's what you guys want to do. Okay, you want to go to math. You want to go all the way down to 8, so the derivative. Now, if you guys are in this chat right now, there's not many of you, but if any of you are in this chat and you're like, calculator's just not working for you, you have a horrible calculator, these steps aren't going to be useful for you, remember, you're going to have the internet. So there's going to be applications you can use, such as, what's the best? Wolfram, I think, is pretty good. Symbolab's not bad. I don't know if Desmos can do derivatives. I gotta imagine Desmos can do derivatives and integrals, so maybe Desmos. But try to reach out to me individually if you guys have questions on that. But anyways, for most of you, the majority of you in here probably, you're gonna want to go to nderiv. Okay, and we're gonna always be with respect to x. It's always gonna be our variable. I know in this case it's t, but we're gonna have to replace t with x. And now I'm just gonna plug in my function f. So I'm going to do arctangent, which is the same thing as tangent inverse. I'm going to use parentheses. So I'm going to put another set of parentheses and put pi over 2 and close those parentheses. And then minus another set of parentheses. In this case, it's t over 10, so we're going to use x over 10. Close those parentheses. I'm going to double check right now, look at all my parentheses, make sure everything is closed that needs to be closed. I think I need to add one more. Okay, so that's all good. Remember, you cannot find a general derivative in your calculators. So you always have to evaluate it at a point, which kind of stinks, but it makes sense. But in this case, it's okay because, right, we want to find f prime of 8. So I'm going to put x equals 8. I'm going to press enter, and that's what I get. All right, so on my piece of paper, I'm going to write that in real quick. I like to do them separately. You don't have to do them separately, actually. You could probably do it all in one step. I'm not going to. Also, Mr. Harris is obnoxious about this. I've told you I'm very OCD about it, so I always write out every single part of the decimal because I want to get exact answers and I don't want to store my value because I'm probably just because I'm stupid. And I don't know. This is what I've done my whole life, so now I'm just stubborn about it. All right, so I just wrote every single value I got for that. If you guys want to approximate and store the value to get the exact answer at the end, fine. Doesn't matter to me. Okay, let me go back then. So that was big F prime. Now let's find L prime. So I want to go to math. Again, 8, so the derivative. I'm still going to be the variable x. And now I'm going to put in the function of L. So I'm going to go back to my question. L of t is 0.03 times 20 x minus x squared minus 75. Close the parentheses so that 0.3 is being distributed. All my parentheses are good. Again, it's the same thing at x equals 8. Press enter, and you get a nice, much cleaner answer of 0.12. My calculator just has an error and I can't do it. So Payne, I believe if I remember correctly, your calculator is not the same as mine. I think you have a TI-82 maybe, one of the older ones. Those ones are different because you don't have this screen where it just says dx and all that. What you have to do is use commas. So you have to do, I forget all the steps. I had a calculator like yours. I can't remember. But what I would do is Google it. And essentially what you're going to have to do is you have to put like the function, you have to put comma, you have to put x, you have to put comma, and then you put your value, so 8. So you'd put 8. So it's basically function, comma, x, comma, 8. Yeah, it's a little bit difficult, Payne, but you'll get used to it after a while. This L is actually easy enough you could evaluate without using your calculator. That one's a pretty easy one to evaluate. Arctangent's doable. It's not ideal, but you could get the derivatives of both these without a calculator if you really needed to. Just not ideal. So, anyways, we got these two values. I'm going to put these in. So negative 0.0627302.602 minus 0.12. And that's what I get, guys. Negative 0.1827. which, remember, we can round to 3 decimal places. So we're always going to do that in AP test, guys. Always round to 3 decimal places. So negative 0.183. Turn my light back on. All right, now I wish I was done, but I'm not. That's my answer. That is W, the second derivative of W at 8. But the question says to interpret the meaning of that in the context of the problem. So guys, this is a big part of this question. I'm gonna try to write this neat. I'm gonna write it in blue. So this is your first part. You got, if this was graded out of 4 points, you got 2 of them. You got half the points. The second point is we have to actually evaluate this in the context. Josh, how does AP feel about truncating? They're okay with truncating. Wait, hold on. Truncating. Sorry, Josh. Yes, they're 100% okay with truncating. So your answer really would be either 0.183 or 0.182. It doesn't matter. They'll accept either. So again, one more time, it's either negative 0.183 or negative 0.182. So you can truncate all you want. I hate it if you're asking me how I feel, but you know what? I'm not AP, so. Anyways, I don't want to bash on Josh. He's just one of those truncators. That's fine. You do you. Let's answer this question. So that's the first part. Second part is this. So what we're saying, the whole context of this problem is saying at time t equals 8, the rate at which the rate of change of the volume of water in the tank is decreasing by negative 0.183. Now the unit's important. Negative 0.183. We still have feet cubed, but instead of per minute, it's per minute squared. So it's feet cubed per minute per minute. That's the second derivative. The normal value is just feet cubed, right? Volume is feet cubed. The derivative is feet cubed per minute. The second derivative is feet cubed per minute per minute. So a lot of nonsense. This is actually one of the hardest, probably one of the hardest ones we've seen all year in terms of like actually writing out what the context is. This was a very difficult one to process. But this is a 100% perfect answer if you guys do it this way. So keywords in my explanation, there's little minor differences. You got to specify it's at time t equals 8. You got to specify it's a rate of change of a rate of change. And you got to specify it's decreasing, and then your units have to be correct. A lot of things. Now, what I'll say, guys, is remember, the nice thing about this problem is that even if you got this wrong, they'll still, I think you still might be able to get 1 point off of your explanation. If your explanation is entirely sound, even though your answer may be wrong, you can still get a point. I can double check on that real quick, but. Yeah, so guys, this total question is worth 2 points. 1 point from this, 1 point from this. So regardless of what you got for here, you can still get half credit by just doing a good enough explanation. So it's really important we know how to write our explanations out. Cool. All right, I'm going to move on. Again, if you guys have questions, just stop me. I'm on my last page. It's going to be part C. All right, part C says, is there a time, t from 5 to 10, at which the rate of change of the volume of water in the tub changes from positive to negative? Give a reason for your answer. Okay. So, is there a time t for which the rate of change of the volume? In other words, remember, the rate of change of the volume is what we call W prime of t, which we know, right, we already wrote this down, is equal to f of t minus L of t. So this is stuff we've already done. We've already talked about, we already know. This is what the question's asking, right? It's asking if, is this equation, is there any point at which that equation between time, so 4 times 5 to 10, is there any point this equation will change from positive to negative? That's all it's asking. The rate of change of the volume going from positive to negative would just be, when does the graph change? Right? So simply put then, what we want to find is, when does W prime of t equal 0? Right? Because we know, potentially, I mean, we don't know for sure, but we know that potentially the graph will change. It has to cross 0. So from 5 to 10, if we can find when the derivative hits 0, we can determine whether it changes from positive to negative. Right? So before we can see if it does or not, we first have to just find that point where it's a possibility. Okay, and so this is the same thing. We want to use our calculator. Now, this one's a little bit easier because we don't have to put any derivatives in. Okay, so using the calculator, all I want to do, guys, is in my y1 row here, I'm going to want to put, because I don't have a function for w of t, so I can't find a derivative of w, so we have to just use the idea that w prime of t is equal to f of t minus L of t. So I'm just going to take my function f of t, which is arctangent of pi divided by 2 minus x, divided by 10, and then minus 0.03 times the quantity 20x minus x squared minus 75. So I'm going to put that all in my calculator. My window's really funky right now. I got to change that in a second. I'm only concerned from the function from time 5 to 10, right? So I want to change my window to, I'm just going to do to 4 to like 11. So I like to go a little bit more just so I can kind of see what's going on. All right, I get this graph, this beautiful graph here. All right, not perfect, but that's okay. I can figure it out. And so the question is, when does it hit 0? So I need that point. So I'm going to calculate my 0. So you go second, trace, and then click on 0. It's going to ask you 2 things. It's going to ask you left bound. It's actually going to ask you 3 things. So you want to go left bound. So above the x-axis, you want to go right bound. Any value below. So what I'm looking at, guys, I'm just looking at y. When the left bound is when y is greater than 0. Right bound is when y is less than 0. I'm going to press enter again on the right bound. It's going to give me a guess. I don't care. Ignore it. Press enter a 3rd time. And it gives me my 0. It's hard to see for you guys. My 0 is at 8.149, blah, blah, blah. So the time where w prime equals 0 is at t equals 8.149287. Okay, and the actual question says, is there a time at which the rate of change, and then give a reason. So yes, there is a time at t equals 8.14. We're gonna evaluate round it to the 3rd decimal, so 8.149 seconds. Is it seconds? No, sorry. It's minutes. At t equals 8.149 minutes, w prime of t is greater than 0 for 5 to 8.149, and w prime of t is less than 0 for 8.149 is less than t, which is less than 10. So this would be my final explanation. So yes, there is a time at which the rate of change of volume of water changes from positive to negative. Reason being is because when from 5 to 8.149, the derivative is greater than 0. And from 8.149 to 10, the derivative is less than 0. So it has to change from positive to negative. Okay, got about 9 more minutes. Should be plenty of time. So D is going to be a little bit tricky question. I mean, not necessarily, but it's you know, if you read D, you can understand. It's just a little bit more complicated than the other ones. And the D is saying that the tub is in the shape of a rectangular box that is 0.5 feet wide, 4 feet long, and 3 feet deep. You guys can draw a picture. I'm not going to waste my time. I recommend you draw a picture. I think it's a great idea. Mr. Harris doesn't draw very good pictures, so I'm not going to do it. Okay, you're just going to laugh at me. So I would recommend drawing a picture. You know what? I'll try. Whatever. Let me try. So we have a tub. This will give you guys your comedic relief for today. So what? You got a tub. Okay. This is going to be so bad. Oh yeah, this is looking good, people. So I don't even know what would I connect after this. We got the base. Oh man, I don't even know, guys. I'm already lost. See, I can't even draw a good enough. I'm not even gonna try. That's my tank. I tried my best. Hope you appreciated it. This is stuff I really should practice, you know. I'm sure there's a way to do it. There's probably a trick that I probably learned at some point. This is why I need to be in person with you guys so someone can go up to the board and draw it for me. Anyways, you're going to draw that. You label 0.5 feet wide, 4 feet long, and 3 feet deep. Thank you, Baron. I appreciate it. So what is the rate of change of the depth of water? Okay, so this is going to be a little bit different, right? Now we're thinking, hopefully, related rates. We have rates. We have a bunch of rates. But all the rates we've been working with have been dealing with volume. The question now is asking for a rate of change of depth, though. So I have rates of change of volume, but I need to find a rate of change of depth. That's your hint as to know to use related rates, that you have different rates that we have to incorporate. Because there is at no point in this question have we talked about depth. At no point. So now they're just throwing this random idea of depth in there. They're asking for a rate of change of depth. We're like, what the heck? Why? Where'd you get this depth from? And they're doing that because you have to use a rate that we do know to compare it, to relate it. And the rate we do know all about is volume. We have a ton of information on volume. Okay, and what we know is the general formula for volume is going to be length times width times height. So 0.5 times 4 times height, h. Remember, it's h because the height's changing. Okay, height's the height of the water. So I realize that the tube or the tub is 3 feet deep, but the height of the water is going to be changing, you know, depending on how much water's in there. So we represent that as h. So in other words, my volume is equal to 2h. Now comes in the portion of related rates. So I need to, if I'm relating rates, I need to first get a rate of change of volume. So in other words, V prime is going to be equal to 2H prime. So if you guys remember from related rates, when we're taking derivatives of both sides, we want to treat it as implicit differentiation. So they're both being derivatives with respect to time. meaning that we have to treat them both implicitly. So v prime equals 2h prime. Now I want you guys to think about this, right? Think about this. V prime is equal to W prime, right? Because the volume, W represents the volume. So the derivative of V volume is the same thing as the derivative of W, which we know is equal to F of T minus L of T. So we're using that idea once again. So if I want to find the volume, or V prime, at T equals 6, because the question asks what is the depth of the water at time T equals 6. So we want to find what is V prime at T equals 6. We're going to take F of 6 minus L of 6. You guys could do that in your calculators. Just go back to the equations, plug in 6, and you get 0.500581. So why am I doing that? Well, because I need that. The rate of change of depth is the same thing as H prime. H prime represents the rate of change of depth because H is giving us our depth of the water. So H prime would be the rate of change of the depth of water. So I needed to do this because now I can get H prime by itself and get values around it. So I'm going to take V prime down here and I'm going to replace it with 0.500581. Set it equal to 2 times H prime because that's what I'm looking for. That's what the question's asking for. Okay, and then you guys just divide by 2. You guys went through algebra. And you got 0.25. Got to have a unit, right? Rate of change of depth of water would be feet per minute. And that is the assignment, people. Perfect timing, too. All right, so about 3 minutes. Any questions you guys got? Lay them on me. Baron, what exactly do we have to submit? Submit a picture of your work, Baron, to College Board. So take a picture, upload it to College Board, and submit the assignment for me to score. All right, well, if you guys are all good, if there's no questions, I hope you have a fantastic weekend. Again, quarter 3 is officially over at 3:30 today. So make sure you guys get your, well, I mean, it really isn't. It's officially over, I think. Grades are officially due next Wednesday, but quarter 4 starts Monday. Yeah, that's fine, Haber. You can take a picture of your whole work. No worries to me. So for all of you guys, if you guys want to just take a picture of all your work, just make sure I see every part of the question on there. And make sure it's big enough where I can actually read it. Because if it's too small, I can't zoom in. It's just a kind of a pain. So as long as it's a clear enough picture, I don't mind that. But yeah, guys, quarter 4 starts Monday. So if you guys have any late work for me, please get it in by 3:30. I'm going to be closing everything up. All the assignments, this week's assignments are going to be closed anyways. But I'll put those grades in starting 4th quarter. So those will be your first grades for 4th quarter. Yeah, have a great weekend, though, guys. Thanks for stopping by. Hopefully this was helpful for you. Go ahead and smash that like, the usual routine. I appreciate you keeping me occupied. Now we'll see you all. Well, I won't see you, but I will talk to you guys Monday. You too, Haber. Thank you. Get some exercise this weekend, guys. Hang out with loved ones. Find some fun stuff to do. Keep yourselves busy. Get your math homework done. All that good stuff. You too, Josh. Thank you. Thank you, Baron. You too. Good morning, Jaden. How are you? Having a hard time spelling today, Jaden? Maybe. Hello to all of Algebra 2. How are you guys doing? I don't know who's in here. Obviously Jaden is, but if anyone else is here, hope you guys are doing good. Good morning, Jared. How are you doing today? All right. Let me get my life together a little bit, guys. I'm all out of whack. So yeah, guys, just so you know, most of you guys are here all the time, so you kind of understand what today is. But if you're not, today's a day where I am dedicating to just review stuff. So any questions you guys had throughout the week, doesn't matter what it is. I don't even care if it's a personal question or anything, just fun to talk about. Whatever you guys want to do, this is your time. Calculus last week, we just kind of talked about pet peeves the whole time. But any sort of math questions, that's my first focus. If you guys are good with everything, don't have anything, you're free to go. This is just to help out with some assignments. So you guys let me know, and I will start answering stuff. So I'm gonna get my book open. I'm gonna get my ALEKS assignment open. All that good stuff. I haven't, Jaden. I don't know what's going on with me, but Jaden, I haven't been drinking coffee. I don't know why. I just just drinking a lot of water. I mean, I've always not. I honestly I enjoy coffee, but I try not to drink it. And the reason being is because it really isn't the best for you. Stains your teeth. Sometimes it messes up your stomach a little bit. So I mean, it's not something like I necessarily want to drink all the time. I only do it because I physically need to drink it all the time or I will pass out. But with this quarantine, I've been getting plenty of relaxation. I haven't been worn out. I know I only have to teach for 3 hours, so I'm not like, it's okay if I get a little bit tired. I don't have to be on my feet all day. So I've been like, I don't really need the coffee. Take a shower, chug some water, and I'm woken up. I don't even eat breakfast, but that's kind of normal. Haven't had my Nutrigrain bars in a while, Jaden. Gotta start buying those again. Finished all my Cliff bars. How about you, Jane? You drink your cup of coffee today? That is disappointing. Brush your teeth at least 2 times a day and coffee won't stain your teeth. Yeah, I don't have any problems with it. It doesn't stain my teeth, but, eventually it might. So, I'll just drink it out of a straw. Did you have coffee, though, Jaden, this morning? Did you enjoy some coffee? You're the coffee king at Vermilion. Absolutely, Jared. Give me the question and we will go over it. I'm on my last page of notebook, guys. Then I might have to go to my whiteboard. Number 8. Fantastic question there, Jared. All these J's in my chat right now. All 2 of you guys. Question 8. That'll do. Jaden, yes, I had a cup this morning. My mom went to Dunkin' Donuts, got donuts and a nice coffee. Wow, Jaden, you're living a life of luxury today. That's awesome. Donuts and ice. Oh, it sounds so good right now. Why did you have to say that? Come on, Jaden. Now I'm going to want that. Damon! Yeah, absolutely. Good to see you. We will do that. Okay, people. So Damon, right now we're doing ALEKS. So if you want to open up your ALEKS, we're going to do number 8. Jared asked for. Jaden, you as well. If you guys want to get that open. Jared, maybe you can try and let's do your problem. So maybe you can give a shot trying to type it in a chat. I think I'll be able to process it. So maybe type that away. We can just do yours so you can get your answer. I feel like a cop today. Maybe a mall cop. You're Paul Blart today, Jaden. Paul Blart, mall cop. Drinking your coffee. Alright guys, we're just going to wait for Jared to type out his question, unless he's ignoring me. And then we will get started. So this is going to be ALEKS. Point 1. ALEKS. Part 1. This is going to be an example of question 8. So this is Jared's question 8. And it says 5y squared plus 22y. I would never ignore you. Okay, Jared. You're full of it. over 25y squared minus 49. Okay, guys. Hold on. I think it might look better without the light on. Kind of like that better. Maybe one light? Maybe that is better. All right, whatever. Okay, so what do we need to do here? So if you guys remember, what we learned on Wednesday was we talked about how we can, in this case, the question's asking you to just simplify. So this is what we talked about. This is the exact type of question we talked about on Wednesday. We want to simplify. And we learned on Wednesday, if you have quadratics, which notice these are both quadratics because they're both squared, in order to simplify quadratics, we have to factor numerator and denominator. So let me start with the numerator. The numerator, we got to always start with a GCF. Is there a GCF with 5, 22, and 21? No way. 5 doesn't go into either of these. All right, so there's no GCF, so we can't do that. Is there a shortcut? Can we take a shortcut? Well, no, because A is 5, not 1. So that's no good either. So now what we got to do is we got to say, all right, let me try to use my Xbox. All right, and the top is going to be A times C. So in this case, it's going to be 5 times 21. Now I'm going to get 105 at the top of my Xbox. The bottom of my Xbox is just my B term, so 22. So I need to find two numbers that multiply to 105 and add to 22. So guys, use your calculators. And I don't know what it is. So I'm just going to keep throwing in some answers, some numbers. So like right away, guys, I'll talk to you what I'm thinking. I'm thinking I know 105 is divisible by 5. So let me try 5. Okay, 5 times 21 is 105, so that doesn't work. But I'm close. I'm pretty close to 22. All right, so let's try 105 divided by 8. 105 divided by 9. No, 105 divided by 7. There we go. Okay, 105 divided by 7, guys. 105 divided by 7 is equal to 15. 15 plus 7 is 22. Ding, 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 ding. Mr. Harris, you did it. Round of applause. Woo! There you go, Jared. Nice. Okay, so now I got my Xbox filled. That's great. Now I can choose what I want to do to get the factor. Most people are going to use the window. Some people group. I'm going to use the window just because, I'm guessing that's probably what you guys would do. So I'm going to draw myself this window here. In the top left, I put my, remember, we're only focused on the numerator right now. Like the denominator, we're completely ignoring for now. The top left of the numerator, I put the first term, which is 5y squared. The bottom right, I put the last term, which is 21. And then the bottom left and the top right, I'm going to put 7y and 15y. That's what I got on my Xbox sides, 7 and 15. So I put those in the corners there. Okay, now I pick a row or a column. I'm going to pick this row here and find the GCF. Well, the GCF between 5y squared and 15y is 5y. And then I just go around the actual window, and I'm going to just see what does 5y multiply to get me all the other values. So 5y times what gives me 5y squared? It's got to be y. Y times what gives me 7y? It's got to be 7. 7 times y is 7y. 5y times what gives me 15y? 3. 3 times 5y is 15y. And then 3 times 7 is 21. So my factored form is then going to be the top of the window, y plus 3, times the side of the window, 5y plus 7. Nice, nice, nice. All right, so I'm going to make like a little arrow. Again, that was just the numerator. So that whole thing was completely the numerator. Now let's do the denominator. Denominator is going to be a little bit easier. The denominator is what we call a difference of squares. Notice, guys, 25y squared is a perfect square. And that perfect square is 5y. 5y times 5y is 25y squared. 49 is a perfect square as well, which we should know, right? 49 is just 7 squared. So when I factor a difference of squares, it's going to be, we have my two perfect squares, 5y and 7. So we multiply the sum of them and the difference of them. So 5y plus 7 times 5y minus 7. Okay, so I got these pieces and parts. I'm going to put them together. So the blue is the numerator. So y plus 3 times 5y plus 7. The red is the denominator. So 5y minus 7 times 5y plus 7. And why do we do this, Mr. Harris? Well, this is the reason. All this work was dedicated just so we could do this. 5y plus 7 divided by 5y plus 7 is 1. So you can cross it out. So your final answer is going to be in this blue box here. Y plus 3 divided by 5y minus 7, Jared. So anyone has questions on that, please ask now. Go ahead and finish writing it down, process it, and then let me know what you think. Yeah, no problem, Jared. Jade and Damon, are you guys okay with that? Any questions on that? Okay, I'm assuming that's a no. All right, so Damon asked then if we could go over page 513 a little bit. So everyone, if you guys need to, Damon, okay, that's good. Yeah, glad that you understand that. I know this is not easy. Learning from home and on your own is not easy. It's not great environment, but yeah, I'm glad to hear. Hopefully the other classes work out too, but I'm glad to hear you're getting stuff here. Page 513 was a little bit more challenging, so I completely understand the confusion. And I don't want you guys to panic. 513 isn't the most important topic in the class. It's important, all of these are important, so we do them, but this one I'm not going to be like mad if no one understands it. Or or I guess I would if no one understands it, but if it's difficult for some people, that's okay. So I'm going to get rid of this notebook. That was me throwing the notebook, in case anyone was wondering. Starting fresh here. And we're going to be doing page 513. So I'm okay with going over these questions. If you guys, let me ask Jared and Jaden. I know you two are still here. If you guys need help with anything else on ALEKS or anything, just let me type in the chat as I go. But if not, then I'll just go over 513 a little bit. So, Damon, before I move on, and I think maybe Isaac, you might be in this by now because I know you emailed me. Go ahead, guys, and type in the chat when you're ready for me to go. So you have your book open, you have your workout ready to go. And then that'll be my cue to start. Nice. All right. Yeah, no problem, Isaac. Just let me know when you're ready. Thank you, Damon. Cool. Thanks, guys. Let's get started then. So let me think. I know Jared for sure, maybe Isaac, but Jared for sure was in the stream Wednesday, and we did go over 1. So Jared, you should already be good with number 1. And number 3, we went over, I think Wednesday too. I think. Trying to remember. Yeah, I think Wednesday. I think we went over 1 and 3 on Wednesday. But regardless, I'll go over again. That's fine. So 1A. It just says, simply put, the half-life of potassium is about 1.25 billion years. Okay? Before you can do anything, okay, we need this formula. Y equals AE to the negative KT. This is going to be like the basis of our work for number 1. Okay, so guys, for this, there's different pieces. Now, I did this in the notes, so I think most of you guys were here. Damon, I wasn't sure. I don't think you could make it. But in the notes from Monday, we talked about this. And what this is this is just a exponential decay formula. All right, so this is an exponential decay formula. And as a reminder, y equals the final amount. A equals the initial amount. K equals a constant, meaning it's just a number, just dependent on whatever the situation is. And T is equal to time. E, if you guys remember, isn't a variable, it's a number. So E is 2.718, just a value that we use for exponentials. All right, so that's all the pieces we need. Now, let's apply this to the actual question we have. So the question says that we have a half-life of potassium that's 1.25 billion years. Okay, so we know then that, I'm going to scroll down a little bit in my paper. In our case, I'm in the black markers, this problem, T is going to be 1.25 billion years. So it's 1,250,000,000. Yeah, 1,250,000,000. That's our time, which is insane, right? My final amount, y, is equal to 1/2. And my initial amount is equal to 1. Now, I talked about this pretty extensively on Monday and Wednesday, so some of you guys, this is just me like a broken record repeating myself. But guys, remember that whenever we have a half-life, all it means is that the final amount is half of the initial amount. I don't care what the initial amount was. It doesn't matter to me. That's why I just call it 1. All that matters is that no matter what it is, it could be 1, it could be a million, it could be a billion, it could be a trillion, I don't care. The final amount's always going to be half of it. So it'll always be that proportion of 1/2 to 1. So in other words, what I have is my equation. I'm going to have 1/2 equals, A is 1, e to the negative k times t, 1,250,000,000. Of course, guys, stop me. It's not a broke record, but it's a grace. I like that, Jay. I've never heard that. That's the truth. So, guys, this is what this formula is applied to our problem. Y is always 1/2 because it's a half life. We're looking for k because Part A says determine the value of k. Our time is given to us. It says 1.25 billion years. Okay, now we're going to solve this, guys. So we're going to take the natural log of both sides. Whenever you take the natural log of a base e, you're left with just the exponent. So I'm left with negative k times 1.25 billion equals to the natural log of 1/2. I'm going to divide to get k by itself. I'm dividing by negative 1.25 billion. Right, so that's going to get rid of the negative 1 and the 1.25 billion. So I get natural log of 1/2 over 1.25 billion. And I'm not really concerned about you guys if you're able to put that in your calculator. Maybe I should be, but I feel like you can put that in Desmos accurately enough. And what you end up getting for k is 5.545 times 10 to the negative 10th. Okay. So any questions for that, gentlemen? Questions from the audience? Nope. Okay, Damon, you okay? I don't know, he might be typing, so I'm just going to give it a second. To start on the next one, though, guys, and Damon, if you're typing, go ahead and keep typing. But to start on B, the only difference is now we're given what the current weight is. Okay, you said I think I'm good. Okay, so let's keep going, Damon. Keep following along. So 1B, now it's saying a specimen currently contains 36 milligrams, which means my final amount, which is today, is currently 36 milligrams. So Y is now going to be 36. All right, so 36 is what we start with. It says, how long will it take the specimen to decay to only 15 milligrams? Oh, okay, I apologize, guys. Let me rewind. Don't write that. We currently have 36. We eventually are going to have 15. So my final amount is actually 15. My initial value today is 36. So Y is 15. Initial amount is 36. Our formula, right, from the beginning, we still have E. We know what K is now. Now we know. K is negative, well, positive, but it's negative K. So 5.545 times 10 to the negative 10th. And the actual question is asking for us to find T. Again, final amount, we're going to end with 15 milligrams. We start with 36 milligrams, so that's Y and A. E always stays the same. It's always our base. Our K we found in the problem before. That was part A. We found K. So we replace K with 5.545 times 10 to the negative 10th, all multiplied by time. Because that's what we're looking for, is T. We have to solve for T. The question says, how long will it take, right? That's the time. Okay, and we're going to go back on this solving logarithms process. So to start, I need to get T by itself, which means I have to get rid of this 36. So to get rid of the 36, we divide by 36, right? So I get 15 divided by 36 equals whatever's left over. So e to the blah, 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 t. Just like last problem, I'm going to take the natural log of both sides. Whenever you take the natural log with an exponential with the base of e, it just ends with whatever the exponent is. So negative 5.545 times 10 to the negative 10th t. Same idea as last problem, so I don't think I need to write this step. You're going to divide by negative 5.45 times 10 to the negative 10th. Put that in your calculator, and you're going to get t equals 1,578,843,530 years. So very, very similar problem to the last. So part B is very similar to part A. Only difference is instead of solving for K, we're solving for T. Questions so far? Okay, cool. Thank you, gentlemen. I'm going to flip the page here. And C, guess what? Same thing. C is the same idea, except now what we're doing, okay, so it says that how many milligrams of potassium-40 will be left after 300 million years. All right, Damon, feel free if you have any specific questions, go ahead. Okay, so C is how many milligrams will be left after 300 million years. All right. Well, we know a couple things. Okay, so I'm going to rewrite this formula just so we have it. So y equals a e to the negative kt. Here's what we know. Okay, if we want to find the milligrams of potassium-40, we can use our half-life. So it says how many milligrams we left after, sorry, let me rewind here. We can label A, so this one's probably the trickiest question of all of them, is because, oh yeah, no problem, Jared. Thank you for stopping by. So for C, this one's a little bit tricky. To find the amount left, we just have, we're looking for Y. Y is, right, we talked about this, Y is the final amount. So that'll be the amount left. We can label A whatever we want. In this case, we're going to label it 1. We're going to assume 1 is A. And the reason why we're assuming 1 is A, let me rephrase that. You're always going to want to label A 1. And the reason being is because this is going to be a proportion. If it's decay, think of A as like 100%, and Y is just some percent of 100%, right? Because if something's decaying, it's going from 100% of itself and losing percents. So we have to make A 100%. or we call that 1 as a decimal. So essentially I have 1e. I know what k is, so let me look back. K is 5.545 times 10 to the negative 10th. In this question, it's saying how much is left after 300 million years. So I write t as 300 million. And we want to find what decimal is y. Alright guys, again, I'm a broken record here. You just put this in your calculator. In Desmos, you put e to the negative 5.545 times 10 to the negative 10th times 300 million. And you will find that you get 30.48 milligrams. Y equals 30.48. Whoops. Were you guys okay with that explanation? Do I need to talk about that or any more? I know it was a little bit long worded, but okay, cool. Yeah, sorry about that. You're right. It did take me a little bit of time to get the words for that. Okay. So let's get on to letter D, not number D. Let's go to letter D then. It says, how long will it take potassium 40 to decay 1/8 of the original amount? Okay, so just like the first question, it was half. It says the half-life takes about 1.25 billion years, so we use the fact that y was 1/2 of A. Now we're saying that y is 1/8 of A. So if A is 1, 1/8 of 1 is 1/8. So essentially we have 1/8 equals e to the, we know what k is. It's 5.545 times 10 to the negative 10th. And then we're looking for t. And guys, same old, same old. So natural log of both sides. Divide by negative 5.45 times 10 to the negative 10th. And you get t equals 3,750,120,003 years. All right, that's all of number 1. It's annoying with these because the numbers are so big. It makes things a little bit more complicated, which I could see how that could be frustrating, but Okay, are we good then? Good to move on? Okay, I think we are. So let's look at number 2. So it says a certain food dropped on the floor and is growing bacteria exponentially according to the model. Damon, yeah, I don't love doing this stuff, Damon. The reason I'm doing it is because it is something you could see on like a standardized test or pre-calculus or something like that. I don't love it either, but this is kind of just where we're at. So 2 says a certain food is dropped on the floor and is growing bacteria exponentially according to the model y equals 2e to the kt, where t is in seconds. All right, so now I'm using a different formula, right? It's similar though, it's exponential growth. That's the only difference. Exponential decay is when k is negative. Exponential growth is when k is positive. We don't have any half-lives, so we don't have to worry about that. So A says if there are 2 cells initially and 8 cells after 20 seconds, find the value for k. So my final value is 8 cells, so y equals 8. My initial value is 2 cells, so a equals 2. I still have my e, that's always my base. I'm looking for k. That's what the question asks. It says find the value for k. And t is time. It says 20 seconds. So instead of writing t, I write 20. So I have 8 equals 2e to 20k. And just like the problems before, I want to solve this. So I'm going to divide everything by 2 to get k by itself. So 8 divided by 2 is 4. And I'm going to rewrite this as 20k instead of k times 20. Okay, we've done this before. I mean, I think hopefully, like the most important thing I want you guys to understand is these steps, solving these. That's crucial. So like here, I would have to take the natural log of both sides. Like I've said before, natural log of e, you're just left with the exponent, so 20k. Divide by 20, that'll give me k. And you end up with 0.0693. All right, not too bad. Like again, like it's like I said, I'm kind of just repeating myself. This is all this process is pretty similar for all of these. Okay, flip the page here. So Part B. Part B says the 5-second rule says that if a person who drops food on the floor eats it within 5 seconds, there will be no harm. How much bacteria is on the food after 5 seconds? All right, so again, we have this formula, y equals 2e to the kt. We want to look at how much bacteria is on the food. So what's the final amount of bacteria? Meaning we're looking for y. So we still have y, 2 is our initial amount, e to the k, which I know what k is now. It's 0.0693. And I know time because it's a 5-second rule, right? So the 5-second rule would be after 5 seconds. So I'm left with y equals 2e to the 0.0693 times 5. All right. And we don't have to do any sort of logarithmic manipulation. We don't have to do anything crazy, right? We already have y isolated. It's by itself. So to solve for y, you just put that in your calculator. And you get 2.828 cells. So that's the amount of bacteria on the food after 5 seconds. Okay, let me ask any questions on the first two parts of 2 from you guys. I think that's too much bacteria. So if you guys don't have any questions, I would like to hear, go in your chat, type in what your answer for 2C would be. Would you guys eat the food that's been on the floor for 5 seconds? Do you eat food? Do you abide by the 5-second rule? And then defend your answer based off the math we did. I know what my answer would be. I'm curious to know what your guys' is. Yes, Isaac, it's much easier, right? I don't eat food off the floor because of all the dog hair, and now after seeing this, I don't want germs. That's a good answer, Isaac. So here's my theory. Okay, I guess not a theory, but this is kind of what I think about. Like, I don't, if you look at that, it's only growing 0.828 cells, which isn't much. But I agree with what you just said, Isaac. I don't think it's a reasonable answer, and the reason being exactly like you said is that it's not just about what's happening on the food; it's about what is on the floor, right? If it's landing in a puddle of like dog, urine or something, I don't want to eat that. Or if it's landing in a bunch of hair, or if it's landing in like anything that's disgusting, or people's like muddy floor shoes that I'm not gonna eat that. It's not about it's about what's already on the floor, not about what's happening once it hits the floor. Now, if it's squeaky clean floors, like freshly Lysoled, like brand spanking new, shiny, I think I'd probably eat it, not have too much hesitation. If it fell on the floor after 5 seconds, maybe even after 10 seconds. But most environments you're in, it's nasty floors, not happening. That'd be my take. So see, guys, moral of the story is it's just completely your opinion. So I just want to see what you guys think for C. And for 3, I'm not going to do 3, and here's why. I'm not doing 3 because I already did it. So if you guys want to see 3 in my explanation for 3, you guys can go to my stream from Wednesday, fast forward to about 2 hours in, and right at the beginning of class, when like I usually do when I go over homework, I go over number 3, the whole problem. Okay, so I want you guys to do that rather than me repeating myself. I had everything in Desmo, so it's a better explanation anyways. So go ahead and you guys can do that. As I said, also, bacteria keeps spreading even after you pick it up and put it in your body. Yeah, for sure. Damn, you said you'd be fine with 5 seconds. Teach his own. Yep, so, as you said, all right. So, yeah, Damien, if you didn't hear me, you can watch Wednesday's stream on YouTube. Just fast forward about 2 hours in, you'll get the answer for 3. I know, Isaac. I need to start marketing myself better. Maybe you could send out a tweet and be like, hey, everyone, go go check out this sweet YouTuber. His name's Mr. Harris. Maybe that'd be beneficial. I'm struggling. I think my numbers are a little down. Not too much down, though. I'm not doing bad. Yeah, shot on your. There you go, Isaac. That'll give me a lot of clout. I'll be having like 1,000 subscribers every minute if you shout me out. That'd be much appreciated. As long as people are smashing that like button, Isaac, I can't complain. Really can't complain. Oh boy. Yeah, so guys, that's pretty much goes over everything. I'll still be here for the next 9 minutes if you guys have any other questions or anything, so you let me know. Yeah, that's what I'm talking about, Isaac. Destroy that button. Dismantle the button. You'll get, if you do an insane house door, I don't know what that is. You mean like the door to my house? Like make it look cool? Is that what that means? Am I missing something here? Ah. Oh, a house tour. Oh, okay. Yeah, there you go. I'll take a video, Isaac, of just myself, just like chilling, and like you can't see anything. And I'll just be like, "Hey guys, this is my house," and I'll just walk around with it like zoomed in on my face and just talk about it. And be like, "I can't show you guys because Corona, but just believe me, there's a water park inside of it. I have my own elevator. It's pretty sweet. I like how you're thinking. Fool all my fans. That's a good call." What's your question, Damon? Go ahead. Yeah, right, Isaac. I agree. How is basketball tryouts gonna work next year? Have you ever, Isaac? Honestly, that's gonna be. We just assume it's gonna be this. Like, I hope we're back. I would like to think that by next year we're back. If that's what you mean. If you mean like because like Corona. Um, I don't know unless you have a different type of question. Yeah, it's gonna be basketball tryouts the same as always. Yeah, Damon. There's a lot of things actually we can talk about. So one recommendation I have for you, Damon, is on YouTube. There is like tons of drills, but the biggest thing, my recommendation is like start with just like the basic dribbling right hand for like 50 dribbles, dribbling left hand 50 dribbles, and just trying to dribble as hard as you possibly can. Like just using your fingertips, smashing that ball against the ground over and over and over again. And just get really comfortable with that and getting your head up. That's also huge. So like every time you do a dribbling drill, try to do it with your head up. But I would start easy with that stuff. Get used to it. And then rotate into other things, such as like figure eight. Like dribbling through your legs. You could do behind the back. Behind the back is a useful move a lot of people use. You can work on that. In terms of drills though, like the internet is endless. So, Damon, dribbling hard helps because the harder you dribble, the harder it is for the defender to steal it, right? If you're slamming the ball against the ground, that ball is going from the floor back to your hand really quickly. Like, the defender can only react so quickly. So if you smash that ball against the ground and they're trying to reach, they're not going to hit it because it's going too fast. If you lightly, like, casually dribble the ball, it's really easy. The defender's hand-eye coordination is quick enough where it can smack it out of your hand, right? So the harder you dribble, the harder it is to steal. Isaac, I want to try out, and all my friends want me to as well, so I've been practicing with dribbles and shooting. Okay, cool, Isaac. Yeah, exactly, Isaac. Ball moves quicker. Yeah, that's good, Isaac. Good. Keep doing that. This is the time. You can really improve with this coronavirus. You don't have much going on anyways, so you guys can put in a ton of work into basketball now. And Damon, I don't know if you're playing football or not, because I know we kind of talked about that, but now's a great time to get better. You can really separate yourselves. Yeah, I mean, at the end of the day, you guys can watch the NBA. You can watch Steph Curry. You can watch Kyrie Irving, how these guys handle the ball. It's like they have a string attached to the ball, and they can do whatever they want with it. You're probably never gonna get to that point, but you got to have in your head like that's what I want to do. I want to be able to do whatever with the ball, what I want with the ball at any point I want to do it. Is essentially what's going on. Okay, so you are going to play football, Damon. Okay, so make sure you're doing those workouts. I'm sure you already know about all that, but make sure Mr. Colahan knows you're working hard and doing all that stuff, because that's got to be your focus. Our football team needs you, so make sure you're doing all those workouts, and that's going to help for basketball too. Every workout for football translates to basketball. Yeah, Isaac, that's a good resource. He did a master class. You have to pay a lot of money for that, but I've always wanted to buy that if I'm going to buy one, because I'd be really interested to see his drills. He's crazy. These people are just someone you can shoot for. No one ever is going to get to that level, but it's fun to just try to model your game after someone like that. One person I really like, Damon, on YouTube is Drew Hanlon. If you YouTube Drew Hanlon, he's really good. Kyle Korver. If you want to play a Kyle Korver, dribbling isn't your focus. If you want to play a Kyle Korver, your defense has to be phenomenal, and your shooting has to be just lights out. Also, Kyle Korver's 6'8", which people don't realize, but he's really, really tall. Not much of a dribbler, though. If you looked at Kyle Korver's dribbling stats from last year, probably put the ball on the ground maybe twice a game at the most, I would say. He doesn't dribble much, but it's still something like, in high school you got to know how to dribble. He teaches shooting now to turn to be Isaac. It'd be awesome if you could prove me wrong. I would like to see you play, Isaac. I've never seen you. I've seen you play soccer. I've never seen you play basketball, but I'm assuming, Isaac, you play guard, right? Point guard, maybe shooting guard. Yeah, exactly, Damon. You do. You have to dribble really good, and dribbling is something our entire team struggles with. So that can separate you if you're a phenomenal dribbler. Part of dribbling, though, is being able to do stuff with it. So not only do you have to dribble so no matter what, can steal the ball from you, but you also have to be able to pass well and score off of dribbling. So basketball's complicated. There's a lot to it. But yeah, I'm glad to hear that you're working hard. I would definitely just Google 10-minute dribbling drill. Google best dribbling drills. There's millions of stuff you can do. Shooting guard or point guard? Nice. So, Isaac, you're a freshman, so you're going to be a sophomore. Okay. I know, just so you guys both know, there's going to be, we're looking maybe 30 people trying out for JV and varsity, potentially. That's how much we have, at least we know of. And, there's always random people that you don't anticipate. So we might have low to mid 30s of people trying out, and we're only going to keep about 20. So that means there's going to be 15 cuts potentially. So it's going to be extremely competitive, which I'm not saying that to scare you. I'm saying it to motivate you. That you got to work way harder than everyone else. You can only play varsity, Damon. You can't play JV. Seniors don't play JV. I never said I didn't think you could shoot, Isaac. I just said you're not going to be able to ever shoot like Steph Curry can shoot. And that's no knock on anyone. That's just because Steph Curry's the best shooter of all time. And there may never be a better shooter than Steph Curry. But if you do, Isaac, I'd be so proud of you. I'd have a tear rolling down my eye as you accept that award. Hey, the pressure's on. I love it, Isaac. That's good energy right there. It's a good attitude to have. That's how I live my life. Nah, Damon. Reggie Miller's fantastic. Don't get me wrong. Big Reggie Miller guy. But Steph's a better shooter. By far. Not by far, but definitely better. Isaac, that is facts. All right, guys. It was good talking to you. Thanks for hanging out. I'm going to go eat some lunch. I'm tired and hungry. So if you guys need any more help with anything, let me know. Go on my YouTube and look at Wednesday's stream. Like I said, like 2 hours in, you guys can see my answer for number 3, and I go through that. So hope you guys have a great weekend. Thanks for stopping by. I will see you next week.